Hello and welcome everyone to Infinity Learn by Sri Chaitanya. I'm Ravindram and we are gonna discuss today the physics portion of your AIIMS weekend test number 20. Okay, let's begin with the first question. So here in the first question, as you can see, they have given in a YDSE, Young's double slit experiment. If there is no initial phase difference between the light from the two slits, a point on the screen corresponding to the fifth minimum has path difference, right? So they want us to find out what will be the path difference between the rays coming from both the slits so that a fifth minimum is obtained there on the screen. So you will say, sir, the simple formula for minimum or dark fringes is delta x is 2n minus 1 into lambda by 2, and since we want it to be the fifth minima, so we have to put, instead of n we have to put 5 here, right? So it will become 2 into 5 minus 1, 9 lambda by 2. So your correct answer will be 9 lambda by 2. I hope you know this thing. For bright fringes, you will say, sir, delta x is equals to n lambda. And for dark fringes, remember that delta x is 2n minus 1, odd multiples of lambda by 2. Right? That is what we have used here. Now, find the right condition for Fraunhofer diffraction to a single slit. We all know that source must be at infinity and the incident beam that is coming should be a parallel set of rays. Do you understand this? So from here we will say third option is correct. Now let's come to the third question. The induced EMF produced when a magnet is inserted into a coil does not depend upon. See, the induced EMF depends upon, induced EMF is actually rate of change of flux. And flux is NBA cos theta. It depends upon number of turns, magnetic field, area of the coil, and the angle of magnetic field with the area vector. But it does not depend upon the resistance, right? Current though definitely depends upon the resistance. It is EMF induced upon resistance. But the induced EMF does not depend. So the resistance of the coil is the factor on which the induced EMF does not depend. Now, the magnetic flux linked with the coil varies with time t as phi equals to 3t square plus 4t plus 9. The magnitude of the induced EMF. Simple. What is induced EMF? Minus d phi by dt. You can see EMF will be, if you differentiate this equation, it will be 6t plus 4. 6t plus 4. Then you have to put the value of time t as 2 seconds. If you put it, and definitely you will get your answer, that is 16 volts. Do you understand? Students, see, what I have done is I have provided you the solution on the screen as well. So in case you are not able to understand that fast, what you can do is pause the video and see the solution also, right? Because I am just hinting out the points here. I'm just marking out the points that this is the point, this is that point. Okay, I've written the equations before only already. I've written all the equations already, right? I'm just showing the lines, I'm showing the equations. But in case you want to understand it thoroughly, you pause the video and see the solution properly, what I have told you here, right? Let's move on to question number 5. Lenz's law is a consequence of law of conservation of, everybody knows it is energy. Please remember this thing, okay? It depends upon the law of conservation of energy. Charge, mass, momentum, no. This is an interesting one. A magnetic field, so they have given you magnetic field B, acts at right angles to a coil of area. Okay, they have given you area also. They have given you number of turns also. The average EMF induced, that means they have given EMF also. So what are the factors that are given? Number of turns, area vector, magnetic field, and EMF, average EMF that is induced. So all these things are already given to you in the question, right? Now what else they need? What if time t, in time t they are saying that the coil is completely removed? So we will say that what is average EMF minus delta phi by delta t. What is delta phi? Delta phi is final flux minus initial flux. So what is initial flux? Initially the angle is 90 degrees, so initial flux is NBA cos 90. Final flux when it is gone out, it is NBA. Oh sorry, there no magnetic field here because it is gone out of the coil. Sorry, I'm very sorry. The coil has gone out of the field, so there is no field lines passing through the coil, so the flux will be 0. So final flux will be 0. So you will say f phi f minus phi I is NBA. What is minus phi? NBA magnitude wise or whatever it is, right? So what is EMF, average EMF induced? Change in flux upon time, NBA upon T. So what is T? Time is NBA upon EMF average. Put the values, get your answer. Answer is 0.1 seconds. I hope you're understanding, right? Seventh question, this is an interesting one. They are saying that one is a very large coil of radius r1 and another one is a very small coil as compared to the larger one, and its radius is r2, and they are placed concentrically sharing the same center in the same plane and are placed in air. The mutual inductance between them. So what is the formula of mutual inductance? See, either you can say phi 1 is equals to m into I2, or you can also say phi 2 is equals to m into I1, right? Phi 2 is equals to m into I1. Now, through which method we should move? This is the question here. See, the problem is we can find out the flux through the small coil. Why? Because the magnetic field at the center of the larger coil, we know the formula for that, okay? And the magnetic field at the center of the larger coil will almost be constant everywhere in the plane of the smaller coil, right? So what will happen? We can say that the magnetic field due to the larger coil, that is what mu naught I1 upon 2R1, right? This we know already, so we can find the flux through the second coil. That means instead of going with this, we will go with this formula. Phi 2 is equals to mi1. Do you understand? Why? Because we can easily find out the flux through the second coil, because we know the magnetic field due to the larger coil at its center, right? But why can't we go with the first formula? Why we can't say that phi 1 is mi2? Because the magnetic field due to the smaller coil at the center we know, but we don't know what is the magnetic field due to this smaller coil in complete this area, because for flux we need a magnetic field throughout the area, right? That is why we can't go with the first formula. We have to go with the second formula. We can find out the flux through the smaller coil. So as you can say, phi 2 is mi1, phi 2 is b1 into a2. Obviously, magnetic field due to the first coil into area of the second coil. Put the values, mu naught I1 by 2R1 is a magnetic field due to the first coil, into pi R2 square is the area of the second coil. Now take out I1 outside, take out I1 out, and you can say mu naught pi R2 square upon 2R1. Now comparing this equation, which equation number 1 with equation number 2, you will get this answer, that magnetic, mutual inductance is mu naught pi R2 square upon 2R1. Now again, question number 8, two coils have a mutual inductance of this 0.005 Henry. The current changes in the first coil according to the equation. So this is how the current varies. The maximum value of EMF induced is, see, we know that what is the formula. First of all, write down what is given to you in the question, my dear students. Mutual inductance they have given, yes. Current they have given, yes. It varies with time, yes. What is the formula for the flux? Phi 2 is mi1, very good. What is EMF induced? Minus d phi 2 by dt, that is minus m di by dt, di1 by dt. Now differentiate the value of current. It will be I naught omega cos omega t. Now we want the maximum value, right? So for that, this should be maximum, and the maximum value of cos omega t is 1. So the maximum value of EMF will become m I naught omega. Put the values, m is given, I naught is given, omega is given, and definitely you will get your answer, 5 pi volts. Did you understand? Yes or no? Pause the video, see the solution. I have explained you this thing. So EMF induced is what? M d I phi 2 is di1 by dt. Just you have to differentiate the value of this current, right? Now, the impedance of a circuit consists of 3 ohm resistance and 4 ohm resistance. Impedance of a circuit consists. So, impedance consists of resistance is given. Resistance is what? 3 ohms. Very good. Now, reactance, we don't know whether it is a LR circuit or CR circuit or LCR circuit. So, we will say XL minus XC. Overall reactance is 4 ohms, right? Now, what is power factor? Power factor is basically R upon Z. Z is the impedance. So impedance will be R square plus XL minus XC mod whole square under root. From there we get this information that Z is what? 5 ohms. Because R is given 3 ohms, XL minus XC. Net reactance is given 4 ohms. 3 square plus 4 square under root is 5. Now you can draw this triangle as well. The vectorial representation, right? Yes or no? Okay. So R is 3, base is 3 ohms, perpendicular is 4 ohms, and the hypotenuse is 5 ohms. What is cos 5? Base upon hypotenuse 3 by 5, that is 0.6. So this is how you will get your answer. Got it? Question number 10. Now in LCR circuit, the potential difference between the terminals of inductance is given, capacitor is given, and resistance is given, and the supply voltage will be. See, there's a relationship. V is equal to VR square plus VL minus VC whole square under root, like this. You apply this formula and get your answer, right? Remember this thing, V is equals to VR square plus VL minus VC whole square what under root. Do you understand this? Now, what is the value of inductance L for which the current is maximum in a series LCR circuit? See, they have given us capacitance, they have given us omega, and they want current to be maximum. See, current is maximum only when Z is minimum, and Z is minimum only when XL minus XC is 0. That means XL is equal to XC, that means a condition of resonance. So you will say omega L is equals to 1 by omega C. So from there you will say omega is 1 by root over LC. Can you see that? So I have applied this here as well. Now you can see the solution, 1 by root over LC. Put the values, you will find out L, that comes out to be 0.1 Henry, 0.1 Henry or 100 millihenry. Students, I hope you are understanding it pretty well. Okay, in case of any doubts, in case you have any doubt, 1 second students, let me shift ahead. Now I am perfectly close to the camera. Okay, now the thing is, I hope you have understood how to find out how when to know that the value of omega. So while what should be the value of omega, so that the current is maximum. Current is maximum when Z is minimum. Impedance is minimum when the resonance has been achieved. Clear? Which one of the following curves represent the variation of impedance with frequency? See, we know that the frequency, there's a particular frequency f is equals to f naught, which is equals to 1 by 2 pi root over LC, where Z is minimum. If Z is minimum here, that means before this Z must have been greater, and after this also the Z must have been greater. So only option number 3 is showing that kind of behavior where Z is achieving a minima at particular point f equals to f naught, right? At the points it is greater than the value which it is achieving at frequency, resonance frequency, right? Question number 30. A circuit when connected, this is an important question. A circuit when connected to an AC source, a circuit is connected to an AC source of 12 volts gives a current of 0.2 ampere. Okay, so there's a circuit. We don't know whether it's a LC circuit, LCR circuit, LR circuit, RC circuit, whatever it is. We don't know which one it is right now. But it is giving zero point 0.2 ampere of the current when it is connected to AC source. And when the same circuit is connected to a DC source, 12 volt, gives a steady state current. See, the thing is, in case of DC, we know that DC, in case of DC current or direct current, we know one thing, that an inductor at t equals to 0 does not allow any current, but at t equals to infinity it allows all the current, right? So inductor allows all the current, but what about capacitor? A capacitor allows all the current at t equals to 0 initially, but after steady state has been achieved, the capacitor blocks all the direct current. So if they are saying that they are having a steady current in DC, that means capacitor cannot be a part of the circuit. That means LCR is not a possibility because it contains capacitor. RC is not a possibility. LC is not a possibility. So the only possibility that we are left with here is series LR circuit. That means for sure it is an LR circuit. This is how we solve it, right? Question number 14, a bulb connected in series, a bulb connected in series with an air core solenoid is lit by an AC source. Okay, see the current is, we should say the IRMS value of the current is ERMS upon ERMS upon what? Upon Z, right? And Z here is R square plus XL square under root. Now power is equals to IRMS square into R. Cool. Power is equals to IRMS square into R. So we can say that somehow power is directly proportional to IRMS square, right? Fine. And we can say that IRMS is inversely proportional to Z, right? So it is inversely proportional to Z square. That means somehow it is inversely proportional to R square plus XL square. Now you tell me what is XL? XL is omega into L, and L depends upon the permeability of the medium. So if you insert an iron core here, then what will happen? Mu will increase, L will increase, Z will increase, and I will reduce. And hence finally we can say power will reduce. So the bulb will glow dimmer. Got it? Next, the power factor of an LR circuit is 1 by root 2. This is an important concept, students. It is asked many a times in examination. Power factor is given 1 by root 2. That means phi is 45 degrees, right? If phi is 45 degrees, that means this is an isosceles right angle triangle. Yes or no? That means this XL minus XC and R, they both are equal, right or not? Perpendicular and base will be same. So just remember this thing. So I will say cos phi is 1 by root 2, that is R by Z. Anyways, that means 10 phi is 45, 10 phi is 1, 10 phi is what? XL by R. Why I am saying XL by R? Because it is an LR circuit, right? It is not LCR, it's just LR circuit. So from here we can say XL is equals to R, equation number 1. Now let's move on to the next part. They are saying that what should be the reactance of a capacitor that should be connected in series in this circuit so that the power factor of the circuit will become 1. See, power factor will become 1 only when phi becomes 0. Phi will become 0 only if the perpendicular is 0. That means in the phasor diagram we can say that it is only resistance left such that XC and XL, they both are magnitude wise same. So XL minus XC is 0, so XL is equals to XC. Now, so XC will be equals to R. Why? Because XL is equals to R. We already know that. So what is the answer? That a capacitance of reactance R should be connected in series, right? Second option is correct. Question number 16. The value of current in two series LCR circuits at resonance is same. See, the value of current into LCR circuits at resonance is same. So both are under resonance. If both are under resonance, that means XL is XC for both the cases. So XL upon XC must be same for both the circuits. That's all. Got it? Question number 17. A resistance of 20 ohm is connected to a source of an alternating potential. Okay. The time taken by the current to change from peak value to RMS. Remember this thing. The time taken to change from peak value to RMS value is always 1/8 of the time period. This is the time from peak value, peak to RMS value. Remember this thing, okay? Now, how to find out the time? See, we know that omega, 100 pi we can compare, omega is 100 pi. Now 2 pi by capital T is omega. From there we can say time is 1 by 50 seconds. But we need the time in which the current changes from peak to RMS value, that is 1/8 of the time period. So it will become this. After solving, it becomes this. Do you understand, students? This is how we will solve it. So remember this thing, that the time taken to move from peak value to RMS value is 1/8. Now 18th question. A transformer has an efficiency of 60% and works at 5 kilowatts. If the secondary voltage is 150 volts, then what is the secondary current? Fine. What is efficiency? 60%. What is the formula of efficiency? 60% means fraction wise it is 3 by 5. Anyway, 60 by 100 or 3 by 5. Now, what is the formula for efficiency? P output upon P input. Yes or no? Output power upon input power. Now, so what is output power? It is 3 by 5. Output power is 3 upon 5 into input power. Now, what is output power? 3. Now, you solve it, you will say output power is 3 kilowatts. That is 3000 watts. So, input power into output. Now, what is output power? Output current into output voltage. Now, output voltage is given 150 volts, right? So, you will say output current will be equal to 3000 upon 150, that is 20 amperes. Did you understand? Very simple. Follow the process. Efficiency is output power upon input power. And what is output power? Output current into output voltage. What is input power? Input current into input voltage, right? Now, in an AC circuit, if an AC circuit consists of an inductor of inductance 0.5 Henry, capacitor in series, everything is given. The current in the circuit is maximum when the angular frequency of AC source is. We know that at resonance the current becomes maximum, and at that moment the angular frequency becomes 1 by root over LC. Put the values, get your answer, right? Question number 20. See, electromagnetic waves, they are produced by accelerating charges. Yes, very right. Do not transport charge. Yes, they do not transport any charge, right? Energy of electromagnetic waves is shared equally. Yes, shared equally between electric and magnetic fields. The energy is shared equally. They travel with the same speed. No. Electromagnetic waves also change their speeds in different medium. So fourth is wrong. 2 and 3 are right. 1, 2 and 3 are right. That means this is right. The displacement current, see, what is the formula for displacement current? The displacement current is epsilon naught dE by dt. Do you understand? What is this? This depends upon the change in electric field. So if electric field is changing with time, then only there will be displacement current. And electric field will change with time only if the potential difference across the plates will change, right? Because what is electric field across the plates? You will say, sir, the formula of electric field across the plates is Q by A epsilon naught. And what is Q? Q is equals to CV, right? Or you can directly say that electric field is potential difference. If the gap between the plates is D, then it is V upon D, right? So electric field depends upon potential difference. So if you change potential difference with time, electric field will automatically change with time, and hence there will be displacement current, otherwise not. So this is a common formula for reflecting surfaces. The momentum transferred is 2 E by C. And for non-reflecting surfaces, then the momentum transferred will be only E by C. The RMS value of the electric field of the light coming from the sun is, so RMS value of electric field is given. The average total energy density. See, average total energy density will be this, epsilon naught E naught square. Remember this, students. Average energy density. This is the formula of average energy density. Epsilon naught E naught square. Just put the values, get your answer. 24. See, the electric field and magnetic field have equal average values. Wrong. They have equal average energies, right? They share equal energies, not equal magnitudes. So this is wrong, this is right. So second option. Question number 25. Now they have given us magnetic field and they have asked average energy density corresponding to the electric field. No problem. See, even if they have given the equation of magnetic field and asked about electric field, we can say that average energy is, in terms of electric field it is this, and in terms of magnetic field it is this, and both are same. So we will find out the energy in terms of magnetic field, and we can say this, since they share the same amount of average energies, So obviously 1 by 4 B naught square by mu naught must be equal to 1 by 4 epsilon naught E naught square. The average energies shared by them are equal. Right? B naught is given, this is B naught. Mu naught, we know the values, just put the value and get your answer. Right? 26. An LCR circuit, series circuit is connected to an alternating current source. When the capacitor is removed, the supply voltage leads the current. Okay, see. So when you're removing the capacitor or capacitive reactance, the supply voltage leads the resultant current by 45 degrees, right? And when the inductor is removed, the resulting current leads the supply voltage to 45 degrees. That means the effect of capacitive reactance and the effect of conductive reactance are same in the circuit. Because if you remove any one of them, the resultant change is by the same angle, 45 degrees. So from here you will say that means XL and XC are same. That means this is the condition of resonance, and hence we can find the value of omega like this. Once you know omega, put the values. Omega is 2 pi f, get the value of f also. Got it, students? Because the change that is occurring after removing any one of them is by same angle. That is why we can say they have same magnitude or same effect in the circuit. Now, using monochromatic light source, Young's double slit experiment fringes have been obtained for a certain separation of the slits. As the slit separation increases, see the fringe width formula is lambda d by d, lambda d by small d. So if you try to increase the distance between the slits, no doubt the fringe width will reduce. So they will narrower. They will get narrow. Understood? 28. A monochromatic beam is used for formation of fringes on a screen by illuminating the two slits in IDSC. Okay. When a thin film of mica, see we all know that. Suppose this is a YDSC apparatus and you keep a thin film of mica here, then instead of obtaining the central bright spot here, you will obtain the central bright spot at a particular height from here. Do you understand? And what is this height? Do you know why? Y is equals to mu minus 1 into, sorry, mu minus 1 into t into capital D by small t, right? This is the height to which the new central bright spot will shift, right? So fringe width remains same, lambda doesn't change, but the pattern shifts in the direction of that slit which is covered with the mica or some other material. Now two coherent light beams of intensity I and 4I are superimposed, the maximum minimum possible. See, we know this formula. What is I max? I max is root I1 plus root I2 whole square. Yes. And what is I minimum? I minimum is root I1 minus root I2 whole square. Put the values, get your answer. Now, the central fringe of interference pattern produced by a light of wavelength 6000 angstrom is found to shift the position by of fourth bright fringe. Shift to the position of the fourth bright fringe after a glass plate of refractive index 1.5 is introduced. That means indirectly what they have given in this question is this. Let me explain you. Indirectly they have said that the position to which it has shifted is actually the position of fourth bright fringe, right? Is actually the position of the fourth bright fringe they have given us. So we will say what is y? Y is, sorry, mu minus 1 into t into capital D by small d, and this is also supposedly the position of fourth bright fringe where n will be 4. So 4 lambda capital D by small d, right? So equation 1 and equation 2, you equate them. Do you understand? That means they have shifted it such that this spot is actually the spot of fourth maxima earlier. So earlier there used to be a fourth maxima here, right? So we will say that mu minus 1 into t is equals to 4 lambda. I guess from here we can solve it. 1.5 minus 1 into thickness is 4 into 6000 angstrom. Do you understand? So answer will be 4.8 micrometer. After solving, 4.8 micrometer. You can solve and get your answer, right? Same again, use the formula. They have given you the ratio of I max to I minimum, and they have asked you the ratio of root. They are asking you what is I1 by I2. I hope we can do this. Give under root on this side, left hand side, and solve it. 32. So what is the formula for intensity on any spot in the screen of IDSC if the I1 and I2 are same? So we can say that if I1 is equals to I2, then the intensity at any point is I max times cos square delta phi by 2, right? So they are asking that there is a point on the screen. Okay, this is the point where delta x happens to be lambda by 3, right? So there is a point on the screen where delta x happens to be equal to lambda by 3. So what is the intensity at this point if maximum intensity is 0.01 watts? So we will say, okay, fine, let's find out what is the path difference they have provided, lambda by 3. So can we convert that path difference into phase difference? You will say, yes sir, k delta x. What is k? 2 pi by lambda into delta x is lambda by 3. We will solve it. It becomes 2 pi by 3, yes or no? It becomes 2 pi by 3. So delta phi is 2 pi by 3. Now we will put delta phi, the value of delta phi in this equation in order to get the intensity at that point. So putting the values, we can say cos square of pi by 0.01. This is what? Watts per meter square. So it is milliwatts per meter square. How much? 2.5. Do you understand? After solving, we will get this answer. It is given 5, but that is wrong. It is 2.5, right? Question number 33. This is an interesting one. They have given that Young's in YDAC first performed in air and then in medium other than air. See what happens when you immerse the complete YDAC setup in another medium. The lambda changes, right? The wavelength will increase, or wavelength will change first of all. Okay, will it increase or decrease? Just tell me. It will decrease. So we will say, sir, lambda dash becomes actually lambda by mu. So we say that beta dash, the new fringe width, becomes old fringe width upon 2. Sorry, upon mu. Right. Now what we will do, we will say, sir, in the medium, and in the air. So in the air, same spot A, in the air is the fifth dark fringe, but the same spot A is the eighth bright fringe in the medium. So what is this? You will say, sir, oh my god, one second. So we will say, sir, what is the height of the eighth bright fringe? You will say 8 beta dash. But what is the height of the fifth dark fringe? You will say, the fifth dark fringe will be like this. See, you can, if you don't want to write like this, you can say like this. So the height of the fifth dark fringe, or just remember this formula. See, the height of the bright fringe is always n beta dash. The height of the dark fringe is always 2n minus 1 into beta by 2. Right? So you will say, what is n here? 8. Here in this question, n is 8. Here in this part, n is equals to 5. So you will say that, sir, 8 beta dash is equals to, put 5 here, 2 into 5, 10 minus 1, 9 by 2. You will say, sir, 9 by 2 beta. Now what is beta dash? It is beta upon mu is equals to 9 by 2 beta. So I suppose this beta and beta will get cancelled. And on solving, you will say, sir, mu comes out to be 16 upon 9. That is 1.778. I guess third option is correct. Did you understand, students? So the fringe pattern actually shrinks in any medium, right? Cool. I hope you're understanding things pretty well. Okay, so let's move ahead to question number 34. Again, the same question they have given that Young's in YDSC. The intensity at a point on the screen is 75% of the maximum value. Use this formula again, that this intensity, this is 75% of this maximum value. So what is the minimum phase difference right now? So we can find using this equation. I is 3 by 4 times I max. So I max will get cancelled. So on solving, you will say, sir, root 3 by 2 is cos of delta 5 by 2. Cos of delta 5 by 2 is root 3 by 2. That means delta 5 by 2 is pi by 6. Phase difference is pi by 3 or 60 degrees. Got it? Simple formula based question. 35. The resolving power of a telescope depends upon the diameter of the objective lens. This is a very common factor. Two slits separated by a distance of 1 mm are illuminated with red light of wavelength 2. So this is, what is this given? Small d. What is this given? Lambda. So what is this given? Capital D. The distance between the third dark fringe and the fifth bright fringe. See, dark fringe means dark fringe बोले तो what is dark fringe? For dark fringe, which dark fringe? Third dark fringe. So y will be 2 into 3 minus 1 into lambda d by 2d. And for fifth bright fringe, what is y? 5 lambda d by d. Now this is your y2, this is your y1. What is the difference? Write it down, y2 minus y1, as you can see here. Delta y is 5 lambda d by 2d. Put the values, get your answer. Okay. Question number 37. Here, when the electron is approaching here, see, when the electron is approaching here, definitely the flux will increase. And when the electron is receding from here, the flux will reduce. Right. So the flux is increasing, then decreasing. So what will happen? The direction of the induced current will change. That is why neither it is clockwise nor anti-clockwise. We cannot say the direction, because they are asking from point A to B, and A to B is complete path in which the electron comes close and moves away also. So if they would have asked only that while it is coming close, what is the direction? While it is going away, what is the direction? Then we could have answered clockwise or anti-clockwise. But they are asking from complete A to B, that means while it is coming and leaving, both. Then we have to say that the current will change the direction as the electron passes by. 38. So the bulb B2, an inductor L, very good, and a resistance R, and two identical bulbs B1, B2 are connected to a battery through a switch S. Okay, the resistance R is the same as that of the coil that makes. That means R is equals to XL, which is equals to omega L. Okay. Which of the following statements gives a correct description? Okay. When the switch S is closed, right? Both bulb B2, see, the bulb B2 lights up earlier than B1, and finally both bulbs shine equally bright. See, the thing is, when you start, initially at t equals to 0, you should remember that current through inductor is always 0. But after steady state has been achieved, I becomes, and what? EMF upon what? Then I becomes maximum, you will say. Okay, then I becomes maximum. Do you understand? This is a direct current circuit, so this concept will not be used. Anyways, do you understand? So the bulb B2 will be powered up immediately, but B1 will be powered up after some time, but both will glow, both will shine equally. Why? Because the resistance of both these coils, circuit AB overall and circuit CD, overall resistance is same, so the bulb will glow equally. 39. When current passing through a choke coil means LR circuit, that means this circuit is a choke coil. Do you understand? The current is decreasing at a rate of 2 ampere per second. The EMF developed across is 10 volts. Energy stored in the inductor is C. Di by dt is minus 2 ampere per second because current is reducing. EMF induced is 10 volts. So the formula is EMF is minus L di by dt. So we will say that 10 is equals to minus L into di by dt is minus 2. So from here you will say L is equals to 5 Henry. Once you know the value of L, then what is the energy? Half Li square. Put the values, get your answer 10 joules. Simple? Yes? Now here, they are saying that this is a wire. The red colored wire is moving with velocity V in a uniform magnetic field B. The length of the wire is L and there is a resistance attached to it through connecting wires. So what is the EMF induced? You will say, sir, EMF induced is BVL. What is the current through the circuit then? Right? What is C? Suppose this is the current through the circuit I. So what is the current through the circuit? I is EMF induced upon resistance. That means BVL upon R. What is power? Power is I square R. That is B square V square L square by R. Do you understand? Put the values. Get your answer. It will be 5 by 2 watts. Got it? Now, if the current is decreasing at a rate of 1000 ampere per second. Now here they are saying that current is reducing at this rate. Find the potential difference between A and B. So step number 1. Di by dt is minus 1000 ampere per second. Step number 2. EMF is minus L di by dt through an inductor. We are talking about this inductor first. Right? Okay. This is 2 ohms. This is 2 ampere. This is 3 volts. This is 1 millihenry. This is B. This is A. I hope it is visible now. Right? So let's move ahead and say that minus L di by dt. What is L? L is 1 millihenry. That means 1 upon 1000 into di by dt is minus 1000. So it is 1 volt. So 1 volt is the induced EMF. Now the thing is current is reducing. Current is reducing. So EMF will be induced in such a way so as to support the current. Because according to Lenz's law, EMF is induced in such a way it opposes the very cause that has induced it. So the cause of induction is the reduction in current. So it will oppose the reduction in current, it will support it. If the current is in this direction, so it can support by getting induced like this. So this is the equivalent circuit now. Start from A. So VA. Now drop in the resistance will be minus 2 IR, minus IR 2 into 2, 4. Again the drop in this battery will be minus 3 volts. Then there will be rise in the inductor. Why? Because it is supporting the current. So plus 1 will be equal to VB. So VA minus VB comes out to be 6 volts. Understood, my dear students? 42. An alternating voltage V. An alternating voltage V 300 root 2 sine omega. So what is the RMS value? So you will say, sir, VRMS is 300 root 2 upon root 2, that is 300 volts, right? Capacitance is given. The reading of ammeter. See, ammeter always reads RMS value in case of alternating current. So it is VRMS upon Z is equals to XC because it is capacitive circuit. So XC is what? 1 by omega C. So this is VRMS upon 1 upon omega C, right? Omega into C. Solving, you will get it is 72 milliampere. Got it? Now another. The power factor of a series RL circuit is 1 by root 2. Now again, same thing. Power factor is 1 by root 2. That means phi is 45 degrees. If it is an RL circuit, that means R, the perpendicular and base are same. That means R and XL are same. So XL is equals to omega L. We know that. Now they are saying if the frequency is doubled, so the new inductive reactance will become 2 omega L. Omega L is equals to R. From here we can say that omega L is equals to R. Right. So XL dash will be 2 omega L. That means 2R. So Z dash will be what? R square plus XL dash whole square under root. So it will be R square plus 2R whole square under root, that is root 5R. Now what is the new power factor? It will be R upon Z dash. The new power factor will be R upon Z dash, right? So it will become what? R upon Z dash, that is R upon root 5R. It is 1 by root 5. Understood? Now, in a series RLC circuit, RMS voltage. Now, see, they have given us RMS voltages. So RMS voltage for resistance is given. The RMS voltage of inductor is given. So overall RMS voltage will be how much? Peak value is given 500 root 2. So RMS value of overall will be 500 volts. Right? These things we know. Now there is a formula if you remember. VRMS square is equals to VR square plus VL minus VC whole square, right? This formula. So if you solve it, you will say that VC is 400. Now this is the RMS value that you have figured out. But we want the peak value. Peak value will be root 2 times this. That means 400 root. So be very careful. You might say that 3 option is right, but it is wrong. They are asking you the peak voltage and given RMS voltage. Yes? Very good. The electric vector of an electron, see this is the relationship. Electric field is magnitude. E naught is equals to B naught into C. That's all. So if they ask you what is B naught, it is E naught by C. C is the speed of light in air or vacuum. A plane electromagnetic wave is given. So they have given us Ez is like this. Ez is equals to E naught cos of omega t plus kx. They have given this. So we know that the speed is v, it is omega by k. Now comparing, the value of omega is this, value of k is this. Put the values, you know v. Now what is the value of refractive index? It is c by v. You know the value of c, know the value of v, put it, get your answer, right? 47. A lamp radiates, now this is a very important thing. See, overall intensity is energy density into speed of light. Remember, intensity is always energy density into speed of light. What is this? I will write down here. Energy density into speed of light. This is very important, right? This is the formula for intensity of electromagnetic wave. So what is energy? What is intensity? Intensity is power per unit area. Power per unit area. So power of your area is what? Complete sphere, 4 pi r square. So putting the values, you will get the value of electric field E naught here, right? In Young's experiment, two coherent sources are placed. Okay, small d is given, capital D is given. Second dark fringe, I think second dark fringe at a distance this. What they want is simple. See, small d is given, yes. Capital D is given, yes. N is given 2. Which fringe it is? Dark fringe or bright fringe? It is dark fringe given. Y is given, yes. So what is it left then? They want us to find out lambda. Okay. So what will you say? You will say, sir, for dark fringe, what is the formula? Y equals to 2n minus 1 lambda d by 2d. Put n equals to 2. This is your answer. Everything is given. Put the values. Your answer will be lambda will be equals to 2d into y upon 3 times capital D. Put the values. Your answer will be there. Now this is the formula. There is a direct formula for the width of the dark fringe. The width of the dark fringe in single slit diffraction, 2 lambda capital D by small d. If you remember this formula directly, just put the values. Otherwise, you can see the solution that I have given you by pausing the video. Okay, again they want us what should be the minimum distance between these two objects A and B so that they are perfectly resolved. What is the formula for power? Resolving power of I? 1 upon delta theta, that is D upon 1.22 lambda, right? So what is this delta theta? This delta theta is x upon s. X, that is the resolving distance, minimum distance between two objects. S is the distance of the objects from the lens. So x upon s, this is 1.22 lambda by d. So from here what you need to find out? X. So x will be 1.22 lambda into s, everything is given upon d. I hope these solutions have helped you students. Thank you so much for watching this video. Please subscribe to the channel of Infinity Learn by Sri Chaitanya. We keep coming with more such videos and we keep coming with other previous year question series, one shot series also on our channel. Do subscribe to our channel and avail all the benefits. Thank you so much for watching this video. Once again, tada, goodbye.